Exponential regression is used to formulate the equation of exponential functions. Exponential regression at least 2 points are needed to make the equation, but typically you're going to have more than that because 2 points don't tell you if it's like a straight line or if it's a quadratic or if it's a cubic. When you have 2 points, it doesn't really tell you what kind of graph it is. So typically we're going to have more than 2 points to determine if it's an exponential function or something else. Exponential regression equations are written this way so that they look like exponential equations. And the values of a and b will be included in the regression output. So b is the base, and a is that vertical stretch factor. So it could be a stretch, it could be a compression, it could be reflecting over the x-axis. Points can be found from graphs. You can see that in this example right here. Points can be found from tables, like in this example right here. And points can be found from descriptions, which you see from this example down here. So it's good to ensure that the model has the best possible fit for all the data that you're using, which if you guys remember, we did this when we didn't do it with sine regression, but we did it with, what was the first regression we did? Quadratic regression, where we had the r squared, and it was the closest it got to 1. So if it had like 0.99999, then we knew that our model was like really, really close to being perfect. Do you guys remember doing that at like the very beginning of the semester? So that's what we're going to be looking at today to make sure that our model is a good one. So go ahead and take your calculator, and we're going to clear the calculator. And the teacher that I got this worksheet from, they actually had this nice little cheat sheet that I printed for you that has all like the things that you need to type to plug everything in. So if you forgot it, you have a nice little like reminder of how to type everything. And I will let you use this on the test or quiz. We'll probably do like a quest situation. I'll let you use this because I like it, and it'll help you guys keep from forgetting this stuff. So this is plugging in stuff on the list. This is making it look like a scatter plot. This is actually getting the equation. 4 is for a straight line. We're going to be using stat, go over to calculate. For this one, we're going to be using number 9 and number 0. Number 9 and 0 to do log regression, which is ln. They're going to do log base e for their log regression. And then exponential regression is 0. So we're going to use not 4, we're going to use 9 and 0. And then over here, turning on r and r squared is how we double check to make sure our line is a good fit. Okay, and then down here, we're going to do this at the same time that we graph, but this is the part where you put a y value in as you're calculating your equation so that it will graph the line at the same time. So this is all the stuff I've taught you how to do, but this is like just in case you forgot. These are the instructions, and they're actually like they make a lot of sense. So if you do brain fart, then this has everything that you need to do, okay? The top part is just the buttons that you would press. The bottom part is like a description of like in words, walking through pressing those buttons. So if you get stuck, just read through that. Okay, so let's go ahead and do the first one. The first page is exponential, and then the second page is logarithmic. So we're going to hit the stat button, and we're going to edit, and we're going to plug in our x values and our y values. 2, 3, 5, 8. And then from this, you can see, like, yeah, it looks exponential because those numbers are growing really fast. So exponential is going to make sense for this one. And then if you want to follow, we can follow the description of what to do. So graphing the scatter plot, this is going to sound familiar since we've done it before, but second Y is what gets us to that scatter plot. Press enter the first time to get into the plot, plus enter the second time to turn it on. And then when you hit zoom and then number 9, that's when you're zooming based on the statistics you just plugged in. Because if you remember, if you go down to 9, it's zoom stat. So it's based on the list you just plugged into stat. So those are all the things that we've done before. It's just written out kind of conveniently for you. So we followed all the buttons of what we've done in the past. Okay, now the diagnostic, I think this is different than we did it before, but I like the way that the other teacher told us how to do it. So let's try this for turning the diagnostic on. So we're going to press the second button and then the number 0. So second 0, and you can see above 0 in blue it says catalog. So we're getting to the catalog of like all the different things your calculator is capable of doing. So second catalog. Then you're going to the X-1 key, which is right beneath the math button, and that's because it has the letter D. So we're going to diagnostics, and we're scrolling down a lot, and we're getting to diagnostic on. So we're getting to diagnostic on because we want to turn on the diagnostic, which is the R squared, so we can see when we have the line of best fit. So we're going to get down to diagnostic and press enter. And then press enter again. That's why it says enter 2 times. And now the diagnostic is on. Everyone follow that okay? All right. And now we're going to do these 2 at the same time. So we're going to calculate our regression, but we're also going to send it to y equals so it will graph it as it calculates for us. So we're going to hit the stat button. We're going to go to the right to calculate. We're not going to go to 4, that's linear. We're going to go to 0 because we're doing exponential. We're going to check that it's using the list that we plugged our information into, so list 1 and list 2. And then instead of going straight into pressing enter 5 times, we're only going to press enter 3 times because what we want to do next is we want to plug in the y value. And the way that we plug in the y value on our calculator is, so I think she was doing it with an older calculator. You can fix this on your sheet if you want to. The way that we type in y on our calculators that are updated is we hit alpha trace. So if you want to rewrite that in on your sheet, because your sheet is a little bit outdated, it's for older calculators, alpha trace, and then y1. So now once we get the equation, it's going to graph it for us. And then we can go ahead and press enter. So now we've got the equation, but we can also graph it. So I'm going to go ahead and write the equation down first. The instructions asked us to round to the nearest thousandth. So y equals 0.333 times, and you can see they told you how to write the equation. A value is the coefficient, B is the base, and then the exponent is x. So 0.333 times 3 to the x. The r squared is 1. That's the diagnostic. They're telling you that the graph went perfectly through every single point. It didn't get close to the points. It literally went through every single point. So if we click the graph button, we'll be able to watch it go through all the points. Okay. We remember all that about regression? Feel good about all the steps? We can do that? Yes? Okay. All right, so you have 2 options. Yeah. Yes. it won't let you plug stuff in. Oh, you know what? Your calculator is not updated.
Oh, perfect.
So it just means your calculator is the old operating system. So grab a different calculator and use a different calculator for today, and I'll update this one. Okay. So now we're going to do problem B. You have two options with this. I would recommend clearing your whole calculator, which means that you're going to do the whole process every time. Every time you're going to turn on the scatter plot, every time you're going to turn on the diagnostic, every time you're going to do all the things. The other option is to not clear your calculator every time, and then you would just write on top of the list. You would put your new list on top of the old list, which would clear it out. You wouldn't have to turn on the diagnostic again. You would not have to turn on the scatter plot again, but you'd probably have to zoom again. You'd have to zoom. You do your zoom 9 again to change the zoom based on the new list, because it would still have the window from the old list. If you do that, then you don't have the repetition of practicing with your numbers to get that muscle memory, pressing the buttons repeatedly. It is up to you, okay? I'm going to clear my calculator so I can practice this over and over and hopefully get muscle memory of like how to type this, okay? You don't have to if you don't want to. It's up to you. Okay. So for B, before I even get started, I'm going to write down my X and my Y values from the graph because the way that they're drawn does not work for my brain. I like to have them in list form. So I'm going to write them down. And then we can go ahead and start plugging them in the calculator. So what I'm doing right now is I'm just following the buttons. I turned on my scatter plot already. Now I'm following the buttons again to turn on my diagnostic. Now I'm going to go and get it to give me the equation and graph it for me. So to get here, you hit the stat button, and you go to the right one to calculate, and you go down to 0. 0. And then list 1 and list 2 are already in there. Those are the default. And then to put Y1, I did alpha trace.
Before that, at the diagnostic thing, you hit enter?
Yes. Diagnostic on, you press enter.
I'm going to that one, right?
Yeah. And you press X -1 to get to the letter D. and then you scroll down until you see diagnostic on, and press enter.
Because on here, it just said lots.
Yeah, scroll down multiple times. Yeah.
I was like, I'm sorry.
Yeah.
Lots. I was like, I have to see that on here.
All right, and then once you have this, we're just going to press enter.
I'm sorry, I'm meaning the Y one.
To get the Y1, you press alpha trace. Trace is right here. It's a great question. I don't know. You can look, you can Google it. I know R squared is line of best fit. I think R is related, but they're calculated slightly differently, and I'm not sure how they're calculated. So, you just read what the options are. So 9 says ln reg, so that's log regression. 0 says exponential reg, so it's exponential regression. It's going to depend on the instructions. So this says exponential function, which is why I knew we were doing 0. Yeah. Sometimes they'll tell you to choose one, and you would do it based on the R squared. So you would try a bunch of different ones, and whichever one had the R squared closer to 1, that's the one you would go with, because you'd say that's the most accurate. What do you do for what? For this, you do 9 if it's log regression and 0 if it's exponential regression. We're doing exponential, yeah. Did everyone get the equation? Yeah? Yes? Okay. Are we ready to try the next one? All right. So we've got the number of years since 2016. So in 2016, that's 0 years. Go ahead and fill out the table. You guys good with the table? Makes sense? Okay. Now, even though this problem is not getting bigger, like our typical idea of what exponential means, we're still using exponential because they still said to do that. So the equation will take care of that for us, the fact that these are going down. It might give us a b value that shows decay, so it might use a decay model, or it might give us a coefficient that would make it smaller. So it'll do something, well, the coefficient wouldn't do that. So it's going to give us a b value that's going to make it a decay model for us. So the calculator will take care of the fact that the numbers are getting smaller. We don't have to worry about that. So you did the whole thing for scatter plot? Did you turn the diagnostic on? If you don't finish it today, you could do 2 days. Maybe they're due as far as like giving you guys an idea of what your grades are going into finals, but not officially for the end of the quarter. Yeah. Because official grades would be due after finals. Because then we calculate everything, so there's still time. All right, are you guys getting your equation? Yeah? Yeah. Okay. All right, is this what we got? Do we have a typo somewhere? So this part right here, you guys, the fact that the base is less than 1 is what takes care of the fact that these numbers are getting smaller, not bigger. That's why it still works to be an exponential model, because it's a decay model instead of a growth model. It's allowing the numbers to get smaller, not bigger. They want you to sketch a graph, so we're going to go ahead and do that. If you don't like the way this graph looks because it's super zoomed in, you can hit the window button and you can back it out just a little bit. Like this, I might make my y min like 0 so I can see it looking like an exponential model. Just kidding, hold on, maybe let me make it bigger. There we go. So I'm going to show you guys what I did for my window. I changed my window to this. So I just adjusted the numbers that they had and I changed them to look a little more normal and less zoomed in. So for my y, I did 0 to 3,500. And then for my x's, I did -10 to 10. -10 is not weird for this because it's just the years. So that means I did 2006 to 2026, so that's reasonable. We'll do a review tomorrow. I need to figure out how I'm going to do your guys' final, so I'll let you guys know. So we'll do some sort of review tomorrow and maybe like a little quiz. We're not going to do like a whole legit test.
Is this one?
Maybe like one regression problem.
Oh, so it's not gonna be the test?
It's not going to be like a whole unit test. We don't have time. All right, we've got 2 questions to answer. So we have to use our equation to predict the value in 2025. So 2025, we're actually not going to plug that number in, obviously. So if 2016 is 0, then 2025 is what number? 9. So we have to plug in x equals 9. So how do I do that? Second trace, number 1, and we're going to plug in 9. Or you could have looked at the table. That would have done it as well.
Mine's saying invalid.
If you didn't change your window, you can only plug in numbers to this that are on your window. So I changed my window from -10 to 10, which is why I could plug it in. But if you didn't change your window when I changed mine, then you wouldn't be able to plug it in. All right, the next problem says use the equation to predict when the value of the account will reach 1,000. So what do we do there? So we're going to make y equal 1,000. In y equals, I'm going to make y2 1,000. And then graph the 1,000. And then what do I do once I have it graphed? I do second trace and I find the intersection, which is number 5. So second trace, number 5, enter, enter, enter. If it says 4.592, when is that? So it's 416, so 2020, 2021-ish. Now, if it says 4.592 and we want it to reach 1,000, which one should we go with? Yeah, you have to think, yeah. Yeah, somewhere in the middle of 2020. I'm just going to write 2020 to 2021. Not the beginning of 2020, that's for sure. but definitely by 2021. All right. All right, for this one, log regression. Is used to model log functions. At least 2 points are needed. One thing that's interesting, we can turn back for a second. Exponential regression and exponential functions are functions that grow really fast. Exponential functions grow really, really fast. So exponential functions are not the fastest growing functions that you can think of. There are functions that grow faster than that, but they're pretty fast. Logarithmic functions are the opposite, which makes sense because they're the inverse. Logarithmic functions are the slowest growing functions we can think of. They're actually even slower growing than linear functions. Even if you think of a linear function that's like this, that grows pretty slow, right? That's a very slow growing function. Logarithmic functions grow slower than that because they go up like this, but then what happens? They level out and they do nothing for a very long time. So these are the slowest growing functions. It's like when you're riding a bike and you think that you're riding something flat, but it burns a little bit and it makes you realize that you're riding uphill, but you can't really tell except that it burns. Does that make sense? Visually it doesn't look like it, but you can tell that you are. That's what a log function is like. So these equations are going to be in the form a plus b times ln x. The b value is that multiplier, so that's for us would be like a vertical stretch or compression, or reflecting over the x-axis. The a value would be like that vertical shift, how far the graph has been shifted up or down. It's written in backwards order for us, but that's how the regression model spits it out, so we're just going to leave it like that because we don't really care. It's fine if they want to write it like that. The logarithm is graphed as the natural log, and it has a base of e. Okay, so let's go ahead and clear this out, and then for this one this time, we're going to use the number 9 instead of the number 0 when we're doing our regression, since they're having us do log regression. Okay, so I'm going to clear my calculator and get my list plugged in. And then since it's the inverse, the numbers that feel like they should be y values are actually x values, and you are doing it correct when you do it that way. 9. So just like the last one, I'm going to change my window so it's not as zoomed in. You don't have to do that. I just think it looks weird that zoomed in. For this part right here, when it says amount of ibuprofen, is that the x coordinate or the y coordinate? Okay. So I can plug this in as long as these x values are in my window. So I changed my window. So 10, 50, and 5 are all in my window. So if I do second trace, number 1, I can just plug them in all in a row and it'll be easy. So I'll type 100 and then write my output. And then I can type 50. And then I can type 5. Yeah. I just changed my window. So my window looked like that to begin with. And then I just zoomed out. I zoomed out so I could see more. So I wrote my numbers so you could see like what I zoomed out to. Yeah, I just feel like when it's this zoomed in, it doesn't make sense to me. My brain just doesn't like that. I don't know. But if you write it this zoomed in, that's fine. You just got to put the numbers there that you used. So the very last problem wants us to figure out which type of regression we should use. So how are we going to know which one works better? We're going to have to do both. And we're going to look at the r squared when we do both. And we're going to see which one is closer to 1. So we're going to have to test. We're going to have to do it twice. So I'm going to go ahead and clear my calculator. And I'm going to type the data in. And I'll follow. You can turn the scatter plot on and look at the scatter plot to give an idea visually of what one you think it might be. I'm going to ignore that. I'm going to do it just by the diagnostic. So I'm going to do just turning the diagnostic on. And now I'm going to do the problem 2 times. I'm going to do it with logarithmic, and I'm going to write down the r squared. I'm not going to graph it because I don't care what the graph looks like. I'm going to do it completely blindly based on the diagnostic. So I'm going to do the logarithmic. I'm going to find the r squared. I'm going to do the exponential. I'm going to find the r squared, and I'm going to compare them. And that's going to tell me which one is better. Okay? All right. So the logarithmic. List 1, list 2, I don't care about graphing it. Oh, probably the logarithmic. Why do I think it's probably the logarithmic? It's literally 1. Yeah. What does the 1 mean? 100% accuracy. It went through every single point on the graph. Okay. And then I'll do the exponential just because it won't take me very much time to do it and compare. This one wasn't terrible, 0.966, but it's obviously not as good as 1. So definitely not correct. Okay. So if you're wondering, how do I know which regression to do? This is it. You do multiple, you compare the R-squareds. You don't have to make the decision just by looking at it, just by wondering. You can make the decision mathematically by comparing the R-squareds. Okay, how do your brains feel about the regression? Pretty good? Okay. I'm going to hand out the practice assignment.